Hello, it's Eric here, and so today we are looking at the final thought experiment in this series of thought experiments. So today is thought experiment number 10, and we're going to revisit the arrow of time. So we've done it before, and we're trying to explain why the arrow of time always flows from the past to the present and then to the future, using the the entropy method. But in this case, in this video, we're gonna explore the arrow of time, to explain why the arrow of time flows like this, using another method. This method is from a very famous physicist, and his name is Leonard Susskind, and so we're gonna use his method to to explain the why the arrow of time always flows like this. And but before I start, you may have noticed that the background music is, again, I'm choosing, a bit of a funky music at the back. And then, by the way, this piece of music is actually composed by Jiro Inagaki. He's a very famous trumpet player or saxophone player from the 70s. And it's one of his most famous funk albums from Japan, of all places. And by the way, if you like Japanese detective drama television series, then you should be very familiar with this kind of funk music, because Japanese 70s detective drama TV series use a lot of this kind of funk music as their background music. And then I'm a big fan of Japanese detective series, like for example G-Man 75. I used to watch that as I grew up, and so that's why I choose that kind of a background music for today's video. But anyway, so let's get back to the arrow of time, and then okay, so according to Leonard Susskind, and the starting point is basically quantum mechanics. So in quantum mechanics, the universe will expand. In fact, it will split itself into two universes. So for example, at the moment now we have one universe, and then in the next moment it's going to be split into two universes. And then in the next moment, then each of the two universes will split into two more. So therefore, the splitting of this universe will create many branches into the future. And so what happens is there are many branches of the universe as time goes on, but some branches are not suitable for human beings. And when I say these branches of the universe are not suitable for human beings, I don't mean that the environment is not suitable for human beings. I mean the physical structure of the universe itself is not suitable for human beings. Like for example, they may have a different speed of light, and then a different force of gravity and things like that. And so in these many branches of universe, many of them are not suitable for human beings, but some of them will be suitable for human beings. And that's why we will be created in those universes, and then we will be there to observe the evolution of the universe. And then so that's not the only thing. As well as time goes on, there are many branches of the universe, and then some are suitable, some are unsuitable for human beings. And at the same time, on top of that, you also have to juggle between expansion and contraction. So as you all know, our universe at the moment is expanding. In fact, it's expanding at an accelerating pace. And then but that is only because we have a certain type of cosmological constant. The cosmological constant in Einstein's equation. And then but in different types of universe, in different branches of the universe, there may be a cosmological constant that is not resulting in the accelerating expansion of the universe. In fact, they may have a very strange cosmological constant that results in some kind of contraction in the universe. And so therefore, some branches of the universe will experience expansion, and some branches of the universe will experience a contraction. And then some branches of the universe will experience both at the same time. So some branches of the universe will contract a little bit and then expand a little bit and then contract a little bit, and that kind of process creates this kind of a vortex, yeah. So this branch of the universe expands a little bit, contracts a little bit, expands a little bit, contracts a little bit. Eventually, it settles down into a kind of equilibrium. This is what they call a fractal vortex, yeah, fractal vortex, I should say, yeah. And then so this is only a fractal vortex for one particular branch of the universe, yeah. But there are other branches of the universe that can experience fractal vortex as well, yeah. For example, this guy here, this branch of the universe, is contracting a little bit, expanding a little bit, contracting a little bit, expanding a little bit. Eventually, it settles down into an equilibrium state, yeah. And that equilibrium state, according to Leonard Susskind, is called a fractal vortex, you know. So there are many branches of the universes, of different universes that can settle down into a fractal vortex, yeah. Fractal vortex here, fractal vortex another here, and then another fractal vortex here, yeah. But then, of course, there are some branches of the universe that will not experience any fractal vortex, you know. Like, for example, this branch will just continue to expand, you know. And then, yeah, so this is like the kaleidoscope, you know. The kaleidoscope, like an amalgamation of all these fractal vortices together with the branches. That will make up, the huge tree of the universes, you know. And it is the manifestation of this this tree of universes, into many fractal vortices, and then many branches. And then as the tree of these universes grows, yeah, you get more and more of these fractal vortices, and then many branches. So it is the growth of this universe tree that is resulting in the arrow of time flowing from the past to the present to the future, you know. Yeah, I hope I have done a reasonable job in convincing you the arrow of time. Yeah, I don't think this explanation of the arrow of time is as convincing as the entropy method, but this is one of the latest cutting edge research methods in explaining the arrow of time. Yeah. All right, so I hope you understand, and yeah, I hope it will not be as clear as much, yeah. And but anyway, so this wraps up the series of thought experiments on philosophy, yeah. And in the next series of videos, we're gonna look at logic, yeah. I'm really excited about the next series of videos on logic, and then yeah, so I'll see you in the next series of videos, yeah. I'll see you then. Bye.